Okay, so this is a CAW Award Science Physics Foundation June 2014 paper. So we're going to look at the part here, we're going to look at current and its relationship of current in a parallel circuit. Okay, so it says a battery is connected to two equal resistors. So I'm just going to underline that, and that's a hint there. Okay, in parallel. So in a battery, the battery supplies a total current of I, which divides into currents I1 and I2 as shown above. Current I1 is 0.4. What is I2? So looking at this, it's told us this here is 0.4. Okay, and looking at my rules for current, I can see that in a parallel circuit, the total current is equal to the sum of the individual branch currents. So that means that at I1, before it splits, the current across these two branches should equal here, A1, and they should also, A2 plus A3 should also equal here. So I've written that down. So before it splits, that's our total current. So we have A1 and we have A4, that's after the splits. So A1 equals A2 plus A3. So this means that the voltage, or sorry, the current at I1 plus the current at I2 should equal the total current here. So because they are equal resistors, that must mean that the current across them is equal. So if I1 is 0.4, that means that I2 is also 0.4. Total current is equal to the sum of the current across these two branches. So I is equal to I1 plus I2. So if we know they're both the same, we have I is equal to 0.4 plus 0.4, which is equal to 0.8, and that's our answer.